TypeScript is a programming language that helps you write better JavaScript applications. Let's look at what TypeScript is and how it helps you write scalable JavaScript code. So here's a definition of TypeScript that I've taken from the TypeScript website itself. It says TypeScript is a strongly typed programming language that builds on JavaScript, giving you better tooling at any scale. Now, what does that mean? How does TypeScript help us write better JavaScript applications? In order to understand that, we need to understand how JavaScript applications work. So this particular slide will help you understand how JavaScript applications work, and then we can build a context of how TypeScript helps us write better JavaScript applications. So whenever you have a JavaScript code, that code is parsed as an abstract syntax tree. Once your source code is converted into AST, this is then passed on to the compiler in order to convert this source code into something known as bytecode. This bytecode is then understood by your runtime environment. This can be Google Chrome or Node.js. Any runtime environment of JavaScript that you're running your code on is able to understand this bytecode and give the final output or the result of your code. Now, this is the story of a JavaScript application. So let's look at how TypeScript application is different from a JavaScript application. In TypeScript applications, you write your application using TypeScript programming language. And here is the difference. TypeScript offers you something known as strict typing, which is missing in JavaScript. I would walk you through an example of code and show you how strict typing looks like. But apart from strict typing, TypeScript also has many other features which are missing in JavaScript. So you write your code in TypeScript, and once you have written your code in TypeScript, it is converted into an abstract syntax tree. And then this abstract syntax tree is passed on to TypeScript compiler now. Now, TypeScript compiler checks your code for valid strict types and gives you errors if there are any errors within your code. And then this code is compiled not into bytecode, but into JavaScript itself. So TypeScript then emits out JavaScript version of code of your choice. So this JavaScript code that is emitted out by TypeScript can now go through its own execution process. This is just like any other JavaScript application and can run in a runtime of your choice. So the whole purpose of TypeScript is to emit out JavaScript code, but having TypeScript gives you the extra functionality which is offered by TypeScript. I would not be wrong in saying that TypeScript can be considered as a superset of JavaScript, which is ultimately compiled down to JavaScript itself. Now, what is the advantage of having this kind of a superset of JavaScript? So if you look at this particular slide, you will see that TypeScript offers many other functionalities which are missing in JavaScript. Static typing, interfaces, type aliases, enums, generics, tuples. The list is long. All these features which help you write scalable code, especially when you're working with large teams, these features are missing in JavaScript. Also, there are some features which are planned for implementation in JavaScript. You get those features in advance in TypeScript. So you write scalable applications using TypeScript, and then ultimately TypeScript does the heavy lifting of converting this TypeScript code into JavaScript for you. So basically any application, any JavaScript application, immaterial of the fact which runtime environment it's going to use, can be written using TypeScript. So this is how the final process looks like. TypeScript code written in TypeScript. Then you get additional functionality which is only available in TypeScript. This code is then converted into JavaScript, which is run by your runtime environment. This is a theoretical overview of how TypeScript works. Let me give you a practical example, a small code snippet written in VS Code so that you're able to understand how TypeScript works. Here we have VS Code opened up, and let me just walk you through the file setup. I have index.ts file. So TypeScript files are all TS files, and this index.ts is converted into index.js, which is the JavaScript file. For the sake of our example, let's go ahead and declare a simple JavaScript function, and then we will try to convert this JavaScript function into a TypeScript function. I have a function over here. The function is add numbers, and the responsibility of this function is to take in two numbers as arguments, a and b, and add these two numbers. Since this is a TypeScript file and TypeScript is throwing errors, I'm just going to add a comment for TypeScript to ignore this particular line of code for the moment. We are going to complete this function as a JavaScript function, and then we'll try to convert this function into a TypeScript function to see how TypeScript works and helps us catch errors. So in order to complete this function, I'm just going to add a return statement, which at the end adds a plus b and returns it from within the function. We can go ahead and invoke this function and check the results. So I'm going to add two numbers first, and then try to add some different values. Just so that we are able to see the result of add numbers on the terminal, let's use a console log statement. Now over here, we have passed numbers as arguments to this function. I'm going to invoke this function once again, but this time I'm going to use one of the values as a string and not as a number. Let's see how JavaScript invokes these two functions. I want to see the final output of these functions. So I'm going to open my terminal, and within the terminal, I'm going to use node in order to invoke or execute these functions. So let's just invoke index.js using node, and let's see the output of these functions. You will see the first line of code as expected adds 1 and 2 and returns 3 on my terminal. But what about the second line of code? Here we added string as the first argument, and then we used number 2 as the second argument. Over here, JavaScript went ahead, converted the number 2 into a string, and then concatenated text along with 2. This might not be what you expect from this kind of add numbers function. You would expect add numbers function to add numbers and not string values and concatenate them by converting numbers to string. This is the problem with JavaScript's dynamic typing. That's the reason you need strict typing in TypeScript. Let's get rid of this tsignore comment and let's see TypeScript, how it helps us catch these errors. I'll close my terminal as well. Now you will see that TypeScript over here says that A and B are of any type, which in TypeScript's language means that this can be any type. It can be a string, it can be a number, it can be a boolean, it can be an object or an array. So how do you add an array to a number? That's the reason TypeScript tells you to define strict types for your function. If I go ahead and say that A is always going to be a number and B is always going to be a number as well, now TypeScript understands that this particular function adds only two numbers, that is A and B. And here it gives us the correct error. Here TypeScript tells us that you cannot add text to a number. By using these kind of strict types within TypeScript, we are able to write better code within TypeScript, which is strictly typed. This is a very small example of how TypeScript can help you write better code. TypeScript has a ton of features which help you write better applications, especially object-oriented code. On a side note, I do have a course on TypeScript, and this course covers all beginner as well as advanced level topics in TypeScript. So starting from the beginner level concepts like arrays, tuples, objects, primitive types, I take you to advanced level concepts like declaration files, namespaces, modules, generics, decorators, and so on. This course has more than 240 videos with more than 22 hours of content. I also show you how you can use TypeScript along with Node as well as with React. The price is pretty nominal and you can check out the course as the link to the course has been given in the description below. That's all for this video. I'll see you soon guys. Thanks for watching.